in greatest common factor factoring, you could have any number of terms. What you're looking at is there any common factor in each term? Okay, so if I'm looking at these three here, right, would you say there's anything in common? 9x squared, 3x, and negative 18. Is there a common factor? 3, right? Once you find the GCF, right, then you take that in front of the parentheses, kind of like a reverse distributive property. Right? And now you're going to put inside the parentheses, what do you get if you divide the 9x squared by 3? 3x squared. Right? What do you get if you divide 3x by 3? Plus x. What did you get if you divide negative 18 by 3? Negative 6. Okay, it should be the case now, if you did distributive property on the right, that you would get back to this expression exactly. Right? If you didn't, then you did something wrong in the way you divided out the 3. In your mind, you may be thinking of it in a different way, like how many times does 3 go into 9x squared? How many times does 3 go into 3x? I mean, whatever way you want to think of it is fine. We see on the next problem why you have to be a little bit careful about that. What does it look like as the greatest common factor between those two terms? 2w, right? Because this one has a w squared. This one just has a w to the first. What's in common is the 1, right? So we would say the greatest common factor is 2w. So again, in a kind of reverse distributive property, we're going to take the 2w out in front of parentheses, and then we're going to say to ourselves, what's 4w squared divided by 2w? 2w. Or what do I multiply times 2w to get 4w squared? 2w, right? Now, what about the second term? If you take the 2w away from 2w, what's left? 1, right? Don't think like, oh, because I took the 2w in front of parentheses, there's nothing there. That would be incorrect. That's why it might be better to think of it like, what do you get if you divide 2w by 2w? And that's clearly 1. If I didn't have a 1 there, what would have happened if I tried to just simplify by multiplying again? I'd be missing a term, wouldn't I? So that's the thing you got to be careful of. Don't forget that there's a 1 left. When it looks like you've factored out the entire term, there's a 1 there. Okay? So that is greatest common factor factoring. And when we learn the other kinds of factoring, we'll learn that there's times when there's a greatest common factor to take out first, and then you have to keep going, and there's something else to do. So that's why it's important to at least check for it every time.